When discussing titrations, they may ask us to do just a little bit of math, but like I said earlier, don't worry, this is just a dilution calculation. The M1 V1 equals M2 V2. This is stuff we've done before, so don't worry, but this is just in a different context, okay? That's all. So number one, let's go ahead and try this one. It says a 15.5 milliliter sample of 0.215 molar potassium hydroxide solution, so that's our base, required 31.2 milliliters of an aqueous hydrobromic acid in a titration. Okay, so that's going to neutralize each other. So we need to calculate the molarity, the concentration of the hydrobromic acid solution, our unknown. So what we're going to do again is the equation, like I told you guys before, is going to be M1 V1 equals M2 V2. That's supposed to be a V or a squiggle, whatever. So our initial volume is 15.5 milliliters. That's our V1. I'm going to multiply it by our first molarity, which is 0.215. Again, notice both of these numbers that I just wrote are for the base. Those are both for the potassium hydroxide base solution. Again, notice I also didn't really care the fact that I put my volume in front of molarity. You guys know from watching my videos, when you multiply two numbers together, the order makes no difference. On the right side, for our acid solution, it required 31.2 milliliters of the acid. And again, what we don't know is our final molarity, or M2. So of course, to solve this, I would take this number here, move it underneath the opposite side. That will cancel that out. Again, this is just algebra. I would take these top two numbers, multiply them together, divide by 31.2. And what I get for my answer is 0.107 molar. That is for our hydrobromic acid solution. So that's the molarity of our unknown aqueous hydrobromic acid solution. Using the known quantities and molarity of our base, our known volume of our acid, we could then calculate what is the molarity of the acid, okay? So number two, it says by titration, 17.6 milliliters of an aqueous perchloric acid neutralized 27.4 milliliters of 0.0165 molar lithium hydroxide solution. What is the molarity of the aqueous acid solution? So what we're going to do is we are told that 17.6 milliliters of our aqueous perchloric acid neutralized 27.4 milliliters of 0.0165 molar lithium hydroxide. So our base is now on the right side, but that doesn't make any difference. What was the molarity of the aqueous acid solution? So again, we don't know our molarity of our acid. So in this case, our acid's on the left, our base is on the right. Again, it makes no difference as long as these two numbers are for an acid, these two numbers are for the base. Again, the order of them really makes no difference. So again, I'm going to divide both of these by 17.6, of course. That will cancel that out. And we get 0.026 molar. And that would be for what? For our perchloric acid. I'm just going to write it out this time. Perchloric acid solution. Okay. So there we go. Again, notice that our volumes are both in milliliters. I do not need to convert those into liters because again, that's going to be the same conversion factor. So therefore, it makes no difference. Do remember though, if one is given to you in milliliters and the other one is in liters, that's a problem. They must be the same, both liters or both milliliters. Beyond that, it doesn't make any difference. So number three, it says how many milliliters? So we're looking for a volume. That's going to be our X of a 1.2 molar solution of potassium hydroxide. So again, that's our base. So our base is on the left now. Now we're going to do the acid on the right. Are required to neutralize 18.00 milliliters of a 3 molar chloric acid solution. Again, you guys know, divide both sides by what is next to the X. That will cancel out 1.2 molar. X, when I multiply the top two numbers and divide by the bottom number, I'm going to get my answer already in milliliters because my other volume's in milliliters. So that would be 45 milliliters of potassium hydroxide, AOH. There we go, guys. So that's quite simple. Again, you just need the acid on one side, the base on the other side. Make sure the volume units match, and then you just solve for whatever you're missing. Again, quite simple, right? That's how you use the dilution equation to solve a titration problem, or application, I should say.